Hello everyone, and welcome to this tutorial about setting up development environment for programming STM8 series of microcontrollers on Linux. A few days ago I wrote an article for programming STM8 microcontrollers in Windows, but somewhere in the article I promised that I will show you how to do this on Linux. When you're on Windows, there's a lot of tool chains and IDEs that you can use. Things are quite straightforward and easy. But when it comes to Linux, it's a bit more complicated, so to speak. So the first thing you need for developing on Linux is the library or compiler called SDCC, and let's go find it. SDCC stands for a small device C compiler, and at the moment the master stable version is 3.5, and unfortunately because I'm using Ubuntu here, as you can see, if you want to install it directly from the repository, you will get an old version, I believe 3.3 or something, and that's not gonna help you much. So what you need is the SDCC version 3.5, which is released somewhere in, I guess, June 2015. So just go to the sdcc.sourceforge.net. You will end up on this page. All you need to do is to go to the download folder, download link, and here you read some stuff that major Linux distributions take care of SCC installation package and stuff, and here it says that unfortunately SCC packages included on Linux are often outdated, and that's the case here. So what you need to do is to do the SourceForge by following that link, and you see here that for example here there's a folder for SDCC for Linux x86. I'm using an 60-bit version of the Linux here, but it doesn't matter. So all you need to do is go to 3.50 and download this link. It's version 3.5, and I have already downloaded it. After you have downloaded it, also you open your terminal, and let me go to my home directory. I will make a new directory here using makdir, and I will call this STM8 dev. So all I need to do is to copy the downloaded version of the SDCC from my download folder to the current folder that I'm in, STM8. Oh, sorry, I forgot. SDCC 3.5. Then let's go to the download folder, STM8 dev, and the file is here. And what you need to do is to type tar xjf SDCC, and this will unzip the file for you. Okay, I remove the archive file 3.5. Okay, I am going to the SDCC folder. I do an ls. Let me get rid of the background so you can see more clearly. and I'm just gonna read through the install file. So the installation is quite pretty straightforward. For Linux, all you need to do after unzipping the archive file is to copy everything to your /user/local folder. So make sure that you do this command so that the binary files goes to your local folder, so you can call the SDCC compiler from anywhere in your system. And I want to tell you something. If you want to use that command to copy everything, then it will also copy these two text files. So I recommend you to not to copy these things, obviously, because they don't belong to the binary folder. Well, they don't cause problem, but anyway. So after this, I have already done this, then I can say SDCC -version to check the version, and it says that obviously the one that I have is 3.50, and it supports STM8 microcontrollers, and it also supports a bunch of more microcontrollers like Z80 or I don't know, PIC 16, PIC 14, and the stuff like that. And after that, let me go one folder back. So here, because I have copied everything, I just need to remove this directory, because everything is already copied to the user folder. SDCC, okay. Now you need the STM8 Flash binary, so you can use it to flash your code on your microcontroller. So for that, I believe one nice Russian guy has made this available, and you just simply need to search for STM8 Flash. So you end up in this GitHub repository. The guy is Valentin Dodoyot. Privet. Как дела, товарищ? Well, okay, so this is the thing you're looking for, STM8 Flash. So all you need to do is to clone it. So let me do this. I will just copy this, and I will go back to my terminal. I will do a clear, so then I will write simply git clone, and I paste the URL. Okay, now I have STM8 Flash in my STM8 development folder. So I switch to this folder. I make a listing. So these are just source files, so you need to compile them, and everything is ready. Granted that you have GCC compiler on your Linux installation, all you need to do have to write make. Okay. After the make is done, you see this the output of the source file is this file, STM8 Flash, and that's the second step. And the next step is to go back to the GitHub again. Oh, sorry, I brought up Qt. STM8 Flash. STM8 Flash. Okay, we are going to the same page, but this time we are interested in another repo, which is called SDCC Examples STM8. So I will go to this. I will again copy the link, and go back to the terminal, make it clear, go one folder back, so I end up in my original folder, and I also do another git clone, and with the new URL. Okay, and you see here that it created this folder for me. I am going to switch into this folder, SDCC Examples, clear, and let's see what files there are. So there's a blinky.c, makefile, readme, STM8L, uart. So there's one problem in this example, and that is if you try to make it, because there's a make file here, you just simply say make. It complains that sptest.ihx is not found. So I think our Russian friend has forgot to remove this from the make file. So we're going to do it ourselves. I'm going to use an editor, in this case Nano, and edit the file. So all you need to do is to remove sptest.ihx from the objects. So the things that we are looking for is the blinky and uart. Blinky is is an example of flashing an LED on your board, the STM8 board, and uart is a more advanced example that we are not going to cover. But anyway, I think that will take care of the problem, and I will save this, go out, and I say make. Okay, you see that the blink example has been compiled to blink.ihx, which is standing for, I believe, Intel hex format or something. And let me show you something else here. Back to my website. Because the board that is used on the example file is for STM8, but my example was given for STM8 S series. So we need to make some changes in the code. And the LED on my board is connected to the port D number 2. So to be able to do that, I've been turning on and off the LED on PD2. I'm going to edit some stuff here in the file blinky.c, and you see here for the example, don't worry about this include file. It says STM8L series, but it also works with S series. So all I need to do is change the port E to port D. Then the DDR is a data direction register. I have explained this in my article in the website. If you are interested, you can go and visit that. And because I'm lazy, I just say set all the ports to output. Also the control registers for all the pins of the port D to 1. And then for switching on and off, I again turn everything to 1. So, and this is a XOR operation. So the first time it will be not 1, and then next time it will be not 0. So it will switching between 1 and 0. And this is just a simple delay. So it will wait for Here it says 29,000, but it actually depends on the internal clock of the chip. So it will be roughly around, I believe, 300 milliseconds. So after this, after these changes, I just save the file again, and I will exit the editor. Then I say here make clean, and make again to reflect our changes. Okay. Now I go back to the previous folder, and I go to the STM8 Flash folder, because my STM8 Flash, as you saw before, is here. Let me clean the window, the terminal. Clear, sorry. Okay. So all I need to do here is to say /STM8 Flash, and I will set the switch -C. Then I use stlink, because my programmer uses stlinkvw. Then I set the switch of P, which is the product, I believe. I will set it to STM8 S003. This is the chip on my board, so you need to change this according to your own board. Then I say I use this switch -W, which stands for write. Then all I need to do is to point it to the compiled version of our Blinky example. So it will be on the previous folder, then on SDCC Examples folder, then blinky.ihx. So after this, you see that I have successfully flashed my chip, and well, you cannot see it here, but I think I have made a mistake because the LED is not blinking. Let me see what's wrong with this. Hopefully I have done my practice and homework before, so I have a working version in my in another directory, and it's in my opt/st micros. I just want to find what mistake I have in the source file. So I go to the SDCC Examples. I will see what's the code, what does the code look like in my working example. So DDR is FF, CR1 is 0FF, and this one is 0XFF. Okay, that doesn't seem like any difference here. Okay, I am going back to my well, this is a nice thing because you can learn some debugging at least. I go back to my home directory, to the new directory that I've made, SDCC Examples. Then I will cat over the blinky.c here. So we have C here. Oh, the mistake is here. I forgot to change the port in this file, so I'm going to do it again. No blinky.c. So I've changed the port from E to D, but I forgot to do it here. So this should make it work. Okay, write, exit, make clean, and after that make. Now I have to do the flash command again. I'm just going back to the history of my commands and do this. And now I had to be in another directory. So the STM8 Flash. Now yes, my board is definitely blinking now. So I hope you learned something from this, and if you had any problems, just leave a comment on the video. I will try to answer your questions. Thanks for watching, and for more information, please refer to my website. And if you like this kind of stuff, make sure to subscribe to my channel, because I will do more stuff. For example, here I had the blinking LED as the part 1 on the Windows development, and part 2 was for the button. So you can simply do the same stuff to be able to, for example, turn on the LED by pressing a button that is connected to your board. So thanks for watching, and see you soon later. Bye.